I'm CK. Tonight I have what I think will be a fun one. It's a little digital voltmeter kit. Just does voltage, I think, and it costs like $8–9 on Amazon. I'll put a link in the description, of course. So we'll see how it goes together. We'll see how accurate it is. I'm not going to place any bets on that. And we'll also see if it's a good learning tool, because understanding how a voltmeter works can increase anybody's knowledge of how a basic circuit works. So we'll put it together, and I hope you enjoy the video. Let's see what's in the package. This is from Hiletgo. I don't think I've done a kit from them before. They've got a support link. They've got a web site made in China. It's a voltmeter kit. It says production suite. I don't know what that means. But let's see what we've got. I'm going to start by taking the piece of paper out and seeing what the piece of paper has on it. Okay, so it's voltage, measuring range from 0 to 30 volts, accuracy 1/10 of a volt, which is not great accuracy, but that's okay. Two-wire system, three-wire system for voltages, and then it tells you how it actually works. Here's a rough schematic, and the second page has the component, and it uses the ATM processor microcomputer for this. Okay, and that's what this is. So you can look that up, look at its data sheet, you'll see everything that this can do. But let's see what parts we get in the kit. It's a bag within a bag, which is always annoying. So it looks like we're really leaning very heavily on the ATM chip to do everything. So that I don't know if there's a lot. Here's the Atmel EGA8L-8PV. Ooh, chips. Pins are very bent, but we can fix that up. So let's see what the actual data sheet for this chip says. Oh, I knocked over my Ferris wheel. Because I don't know if this is actually a dedicated voltmeter chip or whether it's been coded to do what we're doing. ATM EGA8L data sheet. Microcontroller, so it's got a bunch of counters and analog to digital converters. So they're basically using the analog to digital converters in here to measure voltages. Yeah, here it is on the schematic. Here we're coming through here from the input. One side's going to ground, the other side's going over here, and it's going to PC0, and PC0 is the analog to digital converter 0. So that's how it's pulling up the value to display on the LCD display or LED display. But there's the chip. There's the socket for the chip. Here's the digital display, one cap, ceramic cap. So there's only a couple of resistors, probably 10 total. A diode for circuit protection, I'm sure. A trimmer to get voltages, baselines right. On-off switch. One transistor, one electrolytic cap. Now let's look at the motherboard, or the board. Board looks fine. All the values for the components are on the board, so you don't need a build guide, fortunately, because we don't actually have a build guide. The circuit board itself looks good. Oh, it's an EQ kit makes it. A lot of people like this company, OEM from EQ kit. It also looks like it's got a DIY connector here, so you could program the ATM chip, the Atmel chip, if you wanted to. I don't think we're going to do that. Actually, I'm wrong. That is where the switch goes. Never mind. So they don't have pin headers to be able to actually program it. But that's okay. So it looks like a pretty simple build. We'll put it together and see how it looks. I got the soldering iron heated up. As usual, we'll do all the resistors first. So these are the 220s. There are a bunch of 220s. 1, 2, 3, 4, 5, 6, 7, 8. 2, 4, 6, 8. That's 8 of them. And we'll put those on. I'll do one of them with commentary, then I'll do the rest without commentary and speed up the video playback. But I want to see how circuit board responds to solder. And if you haven't done a lot of this stuff, one thing I strongly recommend, you don't have to do this, but when you're putting resistors in or capacitors on the board, pick an orientation that works for you and stick to it. Like for me, when I put resistors on the board, I put the value stripes from the most significant digit goes up or to the left. So the two reds for 2-2 are up, and on the back where these other resistors go, the two reds are to the left. Again, you don't have to do it this way. It's just a convention. You can choose to have them go down and to the right, or any combination you want. The only thing I recommend is you pick one and stick to it. Reason for that is then later on, if something's not working, you need to troubleshoot the board. You want to double check that all your components are correctly placed. Well, if you know where the resistor bands are facing, then you don't have to guess. You don't have to say, oh, am I reading it backwards or forwards? Same thing with capacitors, disc capacitors. Just make sure all the values are pointing one way. So this board is good. The solder worked just fine, flowed well, and sank down into the holes, which means it's a good connection. You're not going to get cold solder joints or anything icky like that. So as I said, nothing much more to talk about for resistors, so I will stop talking and we'll speed up the playback in the video so we can get through resistor time. So besides the resistors, I also put the two 1/10 of a microfarad capacitors on the board, the little orange disc caps. They're to buffer the power going into the microprocessor so it doesn't react to any surges or sags in power. The other thing I forgot to mention is, so the display goes on the front, the microprocessor goes on the back, which is kind of unique. So I'm going to put the socket on next, because I don't want to put the trimmer on before I've got the socket in place. And these pins are also snaggly, so you just take your needle nose, make them all parallel, and drop them through the little holes, and make sure, see, these are not all straight, so I've got to tweak some of these so they're straight. Don't worry about doing that. As long as you're gentle, you're not going to hurt anything, and you do need them to be going in the right direction, don't you? So we're going to put that through, and to solder it on the board, I'm supporting it with my ring finger on the back of the socket, and I'll solder one leg. Let that cool and take a look. Okay, it's all flat to the board, not sticking up at all, so I'll go ahead and solder all the rest of the pins. Now, I normally don't trim pins on IC sockets, and I want to see if I can get away with that here. I think there's enough depth in here that I won't have to trim those off. Did I fill in a hole? I did. I filled in a hole. I got over enthusiastic in one of my solder spots, and I got solder in a hole that I have to take back out. There we go. So if we drop this on, oh no, it doesn't touch the pins there at all. Good. So I don't have to worry about trimming the socket pins. Okay, now that we have the socket on, let's get a bunch more components done. We'll get the diode on now. The indication on the, or picture on the board is pretty good, so you know which side the stripe goes on. Now the transistor, and what they want to do here is we'll put it through the board with the flat side facing that way, and then we're going to kind of lay it over so it lays flat, kind of like so. It's not laying completely flat. Ah, there we go. I'm going to solder this right now too, because I don't want to bounce it around too much. Now we're going to do the same thing with the trimmer. I'm going to lay it down kind of like so. There we go. You're getting the little screw over the little box depicted on the circuit board so you know exactly how you want to get it done. And again, I'm supporting it with my ring finger and soldering one leg, letting it cool, and now I don't have to worry about it anymore. I can solder the others without worrying about it coming out. And we'll put the electrolytic cap in, and the electrolytic also is very clearly marked where the positive terminal goes, the long lead. Zap that one down. Now the switch. Connector on the board. Where is the connector? There it is. We're just going to use a 2-wire connector here. There's provisions for a third, but we're not going to be doing that. Only thing left to solder on is the display. And you want to make sure the dots are down, or else your numbers will be upside down. Oops. So now let's put the processor in. Pins look pretty bent in, so we'll match the notches. I'll put this guy in. I think I got to bend him in a little bit more. And there we go, they're all in. Next thing, final thing, is we have these little brass standoffs that we'll use as legs for this device. I'm not going to use a wrench to tighten them down. This is not going to replace my digital voltmeter. This is just a fun kit. That's how it sits. Now one other thing we'll do is we'll go ahead and put the alligator clips on here. And I'm going to bring my other soldering pad because it grips wire a little bit better than that one. Now, the way I like to put the sleeves back on an alligator clip is I put a screwdriver in it. That keeps the thumb part down enough that I can usually get it over, even though this one's being a little bit of a pain. I may have to get a thicker screwdriver. I do need a thicker screwdriver. Let me use my pokey thing. There we go. Now, clip it in, and that's it. Now, let me go get a power supply, and we'll give this thing a little try and do a little calibration. Okay, so I've got a little lash up going. Oh, one thing you may have noticed along the way, there's no power supply for this. It gets the power from whatever voltage it's sensing. That's why the range that it senses is from 3.5 volts up, because if it doesn't get a minimum of 3.5 volts, it won't turn on. So I've got a power supply here, got my fluke here, to use as a benchmark against it. I'm going to take the voltage down a lot. So on the power supply, I'm showing 0.01 volt, 0.0 volt, and that's what I'm seeing roughly on the Fluke. So now I'm going to turn this on, and we're going to bring up the voltage. Until we can get it to come on. I think it probably did just come on. I'm going to turn off this light. So I'm putting 2.98 volts is what the power supply is reading. As you can see, the Fluke is reading 2.99. And this little dingus is reading 3.9, so it's reading high. We'll go up a little bit more to 4 volts. It's actually 398 coming out, 399 on the Fluke, and 4.5. So we will trim it to get it to meet what the Fluke and the power supply are agreeing on. We will try to. Now, one thing to be careful of, you might have seen the display flicker a little bit momentarily. That's because, oops, I bent the pins up, because as I was trying to hold the circuit board steady, I was bridging some of the pins on the back of the board. So there, that's 4. I'll take it down just a hair. Actually, I'm going to leave it there because 4.0 to 3.996 is pretty dang good. Let's go up to 5 volts. Still reading a little high. Let's go up to 6 volts. Yeah, it's getting higher. I've got my voltmeter, my power supply pegged at 9 volts, so it won't go higher than 8. Let me change the upper limit. Okay, so the upper limit is now at 32 volts. So we can go ahead and crank this up. There's 9. Again, it reads high. It's adding like 1/10 of a volt every 2 volts, 3 volts. I don't think we can trim that out without losing range somewhere else. I've got the current limited 0.2 of an amp, by the way, so I'm not going to be hurting myself if it goes a little close beyond that. Now I'm going to go up to, let's go up to 25 volts. It's 25 volts, and that's pretty good. This is not bad as a little basic voltmeter. Went up to 30 volts and it went out. Huh. Wow. In fact, it flat out died. And this, oh, the voltage range, the measuring range is 0 to 30 volts. And it died at about 30. I'll have to look back at the video, but it looks like it died at about 31 volts. That's interesting. So, it worked for a little bit, but then I overloaded it. I'm not sure what component blew either. I'll have to do some analysis on that. So, this thing absolutely does work with decent tolerances. If you give it too much power, it will blow up, as it just did. So something died in here. But it's a good little kit. I think a youngster could certainly learn from it. And it was a very quick build. So I can recommend this one. Hope you enjoyed the video.